Hello and welcome to this walkthrough video to my AQA Level 2 Further Maths Practice Paper 2. Before we begin, a disclaimer. I first want to point out that this is not a predicted paper. There is no guarantee that these topics will appear at all. Now I have looked at paper 1 carefully to consider which topics haven't come up yet, but don't take this as a guarantee that these topics will appear. Secondly, even if these topics do appear, they may not be asked in this specific way. For most of the topics in the course, there are many different ways of assessing them. So if you really want to practice topics in detail, I recommend going to my website and checking out my topic-based booklets there. I would still consider this paper very good preparation though, but I would study all of the topics again just in case, because there could be topics from paper 1 that also reappear in paper 2. And finally, this is a walkthrough video, not a detailed lesson for each of the topics, so if you struggle with any of these questions, my advice would be leave a comment and I'll try and explain it further for you, or go and look at my playlist covering the course where you can find more detailed explanations on each of the topics. If you want to give the paper a try, you'll find a link to it in the video's description. Otherwise, let's begin. So for this first question, we're going to focus on the left-hand side 3/4 of h. To do 3/4 of something, you just multiply it by 0.75, so this left-hand side could be written as 0.75h. Then on the right-hand side, we've got 85% of h minus 3. So to find 85% of something, you could multiply it by 0.85. So we've got 0.85 lots of h minus 3. Now we can leave the left-hand side as it is and expand the bracket on the right-hand side. 0.85 times h is 0.85h, and 0.85 times negative 3 is negative 2.55. Now we just have an equation to solve in h. I'm going to add 2.55 to both sides first. So on the left-hand side I've still got 0.75h, but I add 2.55, and on the right-hand side that will cancel the negative 2.55 that's already there, so we're just left with 0.85h. Now I'm going to subtract 0.75h from both sides, so that will cancel it on the left, so on the left we're just left with 2.55, and on the right 0.85h take away 0.75h is 0.1h. The final step is to divide both sides by 0.1, and this will give you the answer 25.5. In this question we've been given a ratio for AB to AC, and that's 2 to 5. This means if we look at the length from A to B, we can say that's 2 parts, and the length from A all the way to C, that's 5 parts. Now this means the length from B to C, which is this one here, must represent 3 parts. So we're now going to work out how we get from A to B. To get from A to B horizontally, we need to look at the x-coordinates. You can see the x-coordinate goes from 2 to 18, so if we do 18 take away 2, we find the horizontal length there is 16. We can do the same thing with the vertical coordinates. So it goes from 6 to 36, so if we do 36 take away 6, we get 30. So to get from A to B, we'd go right 16 and up 30. Now remember, this line represents 2 parts of our ratio, so if we half both of those, we'll get 1 part. So let's half 16 to get 8, and half 30 to get 15. This means 1 part must be 8 across and 15 up. Now we want 3 parts to get from B to C, so we can multiply these by 3. So 8 times 3 is 24, and 15 times 3 is 45. This means to get from B to C, you would go right 24 and up 45. So let's go from B to C. So if we're already at B, our x-coordinate is 18 and our y-coordinate is 36. To get the x-coordinate for C then, we're on 18 and we add 24 to get 42. And to get the y-coordinate, we're on 36 and we add 45, which gives you 81. So the coordinates of C must be 42, 81. In this question we have a matrix and a point, and we need to transform that point using the matrix. To do this, we take the matrix, so which is 1, 2, 0, 1, and we multiply it by the coordinate written in a column vector form, so 3, negative 2. To do this multiplication, we're going to look at these 2 numbers here and these 2 numbers here. So to get the top number, we would do 1 times 3, and then add to this 2 times negative 2. 1 times 3 is 3, 2 times negative 2 is negative 4, so we've got 3, take away 4, which is negative 1. Then for the bottom number, we need to use this pair of numbers with this pair of numbers. So we need to do 0 times 3, which is 0, and 1 times negative 2, which is negative 2, and 0 plus negative 2 is negative 2. We can now write this in a coordinate form, so it's negative 1, negative 2. In this question, we have an equation to solve, but the x values are the indices. So what we're going to do is write out the equation, and I'm going to start by trying to remove the fraction by multiplying both sides by 5. If I times by 5 on the left, I get 25 to the 2x, and that 5 cancels, and on the right I've got 5 to the x, but I times this by 5. Now when you multiply with indices, as long as the bases are the same, you can add the powers. So we've got 5 to the x times 5 to the 1, so that must be 5 to the x plus 1. Now we can do something with the left hand side as well. 25 is 5 squared, so let's replace that 25 with 5 squared, then we have 5 squared to the 2x. And then when you have a bracket raised to a power, you could just multiply the powers. So we're going to do 2 times 2x, which is 4x. So on the left hand side, this is 5 to the 4x. We've now written both sides as a single power of 5. So these powers here must be equivalent. So 4x must equal x plus 1. We can now just solve this equation. If we take away 1x from both sides, on the left hand side we get 3x, and the right hand side we get 1, and then divide both sides by 3. This will give you x equals 1/3, which is the answer to the question. In this question we have a ratio. We're going to look at each part of it separately. So first of all, we're going to look at this x plus y, which represents 7 parts of the ratio. So we can imagine in a really simplistic case that x plus y equals 7. If we do the same thing for the right hand side of the ratio, then we've got x minus y representing 1 part, so x minus y could equal 1. We now just have some simple simultaneous equations to solve. If we add the equations together, we get x plus x, which is 2x, y plus negative y gives you 0, and then 7 plus 1 gives you 8. Then we can divide both sides by 2 to get x equals 4. If we then substitute this x value into one of our equations, I'm going to go for the first one, then instead of x plus y equals 7, it's 4 plus y equals 7, which gives you a y value of 3. This means if I was going to write the ratio of x to y, it would equal 4 to 3, which is the answer to the question. In this question, we need to simplify an algebraic expression. We're first of all going to focus on the numerator. Here I can see we've got the bracket x plus 2 in both of the terms. In fact, we've got it twice in both of the terms, so we can factorise x plus 2 squared out of it. If we were to factorise x plus 2 squared out of the first term, we'd still need that x that comes before the brackets, and we'd also still need this x plus 2 one more time since it's cubed in the expression. So it would be x, brackets, x plus 2. Now for the second term, it's negative 8 lots of x plus 2 all squared. Now we've already factorised out the x plus 2 all squared, so we just need a negative 8. So now we've factorised out that x plus 2 all squared, we're going to simplify what's inside this big bracket here. So if we keep the x plus 2 all squared, if we expand that bracket there, it would be x times x, which is x squared, and x times 2, which is 2x. And then we've got this negative 8. Now inside these square brackets, you can see we've got a quadratic expression here, which fortunately also factorises. So we've got x plus 2 all squared, then inside this quadratic we can factorise it, is x plus 4, x minus 2. So our fully factorised numerator is this. But then this is over a denominator of x squared minus 4. So let's look at this x squared minus 4. You should spot that that's the difference of two squares, so it can factorise to x plus 2, x minus 2. And now we've got some cancelling to do. You can see we've got x minus 2 at the end of both of those, so we can cancel those out. And then we've also got an x plus 2 twice, so we can cancel it from the bottom and one of the brackets from the top. So I'm just going to cross the squared out. This leaves me with x plus 2 on the top and x plus 4, which is the answer to your question. You don't need to further expand this out, this is already simplified fully, but if you did, you wouldn't lose any marks, as long as you did it correctly. For this question, we need to find an expression for the rate of change of y with respect to x. This is just asking you to differentiate it. So what we're going to do is take the question, and then we're going to rewrite it as two separate fractions. So we've got y equals, and then we could write it as 9x over x squared, and then minus 3x squared over x squared. Now if we look at each of these fractions separately, on the first one we've got an x over x squared. When you divide like this, you subtract the indices, so we need to do 1 take away 2, which gives you negative 1. So we could rewrite this as 9x to the power negative 1. On the right hand side, the x squareds will just cancel, so you just end up with 3. Now written in this format, it's a lot easier to differentiate. So we're going to do negative 1, that's the power, times the coefficient, which is 9. That gives you negative 9. And then we reduce the power of the x from negative 1 down to negative 2. So we get negative 9x to the power negative 2. And then this negative 3 is a constant term, and when you differentiate that, it gives you 0. So this is just the answer to the question. Negative 9, x to the power negative 2. If you wanted, you could rewrite this as negative 9 over x squared. That would also be fine. In this question, we've been given a sequence, and we need to find the two terms where the sequence gives a value of 0.5. So let's just write our nth term equals 0.5, or perhaps 1/2. So what we can do now is multiply both sides by 3n squared plus 15n, and also both sides by 2, and that will remove the fractions altogether. So on the left hand side we get two lots of 2n squared plus 13, and on the right hand side one lot of 3n squared plus 15n. Now we can expand those brackets, so on the left hand side 2 times that bracket gives you 4n squared plus 26, and on the right hand side one lot of that bracket is just the same bracket. What we have now is a quadratic equation. We're going to get all of the terms on the left hand side, so if we subtract 3n squared first, that will give you 1n squared plus 26 equals 15n, and then if we subtract 15n from both sides we get n squared minus 15n plus 26 equals 0. We can then factorise this one, it gives you n minus 2, n minus 13 equals 0, and this gives you two solutions, n equals 2 and n equals 13. For the second part of this question, we need to write down the limiting value of the sequence as n tends towards infinity. So if we look at both the numerator and denominator for this fraction, they've both got an n squared term, which means this constant term here and this n term are going to get dominated as n gets very, very large, so they become insignificant. So as n becomes very, very large, we just need to look at 2n squared over 3n squared. Here the n squareds will cancel out, leaving you with 2/3, which is the answer to the question. For this question, we've been given a piecewise function and we need to define it. So let's look at the first piece, which is this one here. To find the equation of this one, we're going to start with its gradient. So if I just pick 2 points like this and draw a gradient triangle, you can see quite quickly that the gradient of that one is -2. So it's going to equal -2x, and then we need the intercept of the graph as well, which you can see is up here at +3, so it's -2x plus 3. We also need to give the domain for this, so this is when x goes from 0 to 3, so 0 to 3. And onto the next section, which is this horizontal line here. You can see that always has a value of -3, so this is just -3, and it's for x values between 3 and 5. And now onto the final section, which is this one here. So we're also going to do a gradient triangle, and the gradient of this one is just 1 over 1, which is 1. So we know it's going to be 1x, but we don't have the intercept, and it's also not so clear this time because this part of the graph doesn't touch the y-axis. So what we're going to do is write out y equals 1x plus c, where c is the intercept we're trying to find. Then we pick a point that's on this section of the line, so I'm going to go for this one here, which has coordinates 6, -2, and we substitute x for 6 and y for -2. So let's replace the y with -2, the x with 6, and then plus c. If you now take away 6 from both sides, you find that c is -8. So this final section of the graph is 1x minus 8. And it's for x values from 5 to 6. And that's our completed function. In this part of the question, we're looking for an x value where the function is not defined. Since we have a fraction here, we know the denominator cannot equal 0. So let's look at this 5x plus 1, and let's imagine what value of x we would get if this were to equal 0. So if 5x plus 1 equals 0, take away 1 from both sides, then 5x will equal -1, and divide both sides by 5, then x will equal -1/5. So this function is not defined when x equals -1/5, since you'll get 0 on the bottom, and you can't do 3 divided by 0. For the second part of the question, we're looking for the range of this function, and the graph is sine of x. So let's draw a quick graph of sine of x. So we draw some axes like this, and we know it goes between 1 and -1, and it starts at 0, goes up like this, comes back down, all the way down to -1 and back to 0 again. Now you need to be really careful on this question because they've given you a restricted domain here of x is in between 180 and 360. So we're only actually interested in the second part of this graph. So if we remove the first part, you can see we're only needing this part here, so the range for this one is actually from 0 down to -1. So we would write the range, which is h of x, is in between -1 and 0. For this question, we need to find the range of values of x for which this is a decreasing function. If the function is decreasing, then dy by dx must be less than 0. So let's differentiate this function first. dy by dx would equal, we're going to do the power 2 times the coefficient 2, which is 4, and reduce the power of x down from 2 to 1, so it's just 4x. And then for the plus 20x, when we differentiate that, we can just drop that x, and we're left with 20. So if this is dy by dx, we need this to be less than 0. So 4x plus 20 is less than 0. If we subtract 20 from both sides, we get 4x is less than -20, and then divide both sides by 4, we get x is less than -5, which is the answer to the question. For this question, we need to use the factor theorem to show that 4x minus 1 is a factor of this. If 4x minus 1 is a factor, then when we substitute in 1/4, we should get 0. So let's do f of 1/4. So we're going to do 4 lots of 1/4 cubed, plus 23 lots of 1/4 squared, plus 30 lots of 1/4, minus 9. Now let's start with the cubing and the squaring. So we've got 4 lots of 1/4 cubed. Well, 1/4 cubed is 1/4 times 1/4 times 1/4, which is 1/64. 1/4 squared is 1/4 times by itself, so 1/16. And then we've got 30 quarters and minus 9. If we now multiply all of these brackets, we get 4 lots of 1/64, which is 4/64, 23 lots of 1/16, which is 23/16, 30 lots of 1/4, which is 30/4, and then minus 9. Now to really clearly show that this equals 0, I'm going to write them all over a common denominator. I'm actually going to go for 16. The first one will simplify if you divide them both by 4 to 1/16. The 23 is already over 16. If we want to get the 30/16, we need to multiply top and bottom by 4, so we get 120/16. And to get the 9/16, we need to do 9 times 16, which is 144/16. You can now see that this equals 0, because if you do 1 plus 23 plus 120, and then minus 144, you end up with 0/16, which is 0. So we've used the factor theorem to show that 4x minus 1 is indeed a factor. For the second part of the question, we now need to fully factorise this. There are a few different ways of doing it, but I like to use long division. So I'm going to take our function and then divide it by the factor that we just found, 4x minus 1. So what I'm trying to do here is work out how I can get 4x cubed by multiplying something by this 4x. So to get 4x to 4x cubed, I need to multiply it by x squared. You could do this by doing 4x cubed divided by 4x if you want. Now we multiply this x squared back by the whole factor. So x squared times 4x is 4x cubed, and x squared times negative 1 is negative x squared. We then do a subtraction for these terms here. 4x cubed take away 4x cubed is 0, and 23x squared take away negative 1x squared. Well, when you take away a negative, you add, so that gives you 24x squared. We then bring this plus 30x down. And we can just repeat the exact same process again, so now we're trying to get 24x squared using this 4x. Well, this time we multiply it by a positive 6x. We then multiply this positive 6x back by the 4x minus 1. 6x times 4x is 24x squared, and 6x times negative 1 is negative 6x. And then we subtract these terms here. The 24x squareds will cancel. 30x take away negative 6x. Again, we're taking away a negative, so we need to add it. So that's 36x, and we drop this negative 9 down. And finally, we're looking to get this term here, using the 4x. We need to multiply that by plus 9. So multiply back through by plus 9. 9 times 4x gives you 36x. 9 times negative 1 gives you negative 9. Then if you subtract these last two, you'll see you'll end up with 0. So we've managed to show that when we divide f of x by 4x minus 1, we end up with x squared plus 6x plus 9. Now this is a quadratic that can also be factorised once more. X squared plus 6x plus 9 is actually just x plus 3 times by x plus 3. So this is the fully factorised version, which is the answer to the question. In this question, we've been told the nth term of a sequence is an minus bn squared, and we've also been told that the first term of the sequence is equal to 7. If this is the first term, then if we substitute 1 in for n, we should get 7. So let's substitute 1 into the expression for the nth term. This just means replacing all of the n's with 1. So we've got a times n, so a times 1, minus bn squared, so minus b times 1 squared, and this must give us 7. Well, a times 1 is just a, and 1 squared is 1, so b times 1 is just b. So we end up with a minus b equals 7. Now we've also been told that the fifth term of the sequence is equal to negative 5, so we can do the same thing by substituting in 5, we should get negative 5 as the answer. So we've got a lots of 5 minus b lots of 5 squared should give you negative 5. A lots of 5 is just 5a, and 5 squared is 25, so we get 5a minus 25b equals negative 5. We've now managed to form two simultaneous equations. We've got a minus b equals 7, and also 5a minus 25b equals negative 5. We can solve these by multiplying the first one by 5, so we get 5a minus 5b equals 35. If we subtract the equations, then 5a take away 5a is 0, negative 5b subtract negative 25b is a positive 20b, and 35 subtract negative 5 is 40. Now divide both sides by 20 and you get b equals 2. We can substitute this back into one of the equations. I'm going to go for the first one here. So a minus 2 equals 7, and if you add 2 to both sides, you find that a equals 9. So we now know the values of a and b. So if we return back to our nth term from the start of the question, it's an minus bn squared. So let's just replace the a with a 9, and the b with a 2. So it's 9n minus 2n squared. We've been asked for the 20th term in this sequence, so we need to substitute n for 20. So we need to do 9 lots of 20, subtract 2 lots of 20 squared. You can type this into your calculator and you get the answer negative 620. In this question, we need to describe the transformation represented by the matrix M. If you ever have a constant number on the leading diagonal of this matrix and zeros everywhere else, you end up with a matrix which represents an enlargement. You should know this one is an enlargement, scale factor k, center 0, 0. Now for the second part of the question, we need to describe the transformation for matrix M squared. So let's work out M squared first. That would just be the matrix M times by itself. So we'll end up with another 2 by 2 matrix. We need to do k0 with k0. So k times k is k squared, 0 times 0 is 0, so it's k squared plus 0, which is k squared. Then k0 with 0k. Well, k times 0 is 0, and 0 times k is also 0, so 0 add 0 makes 0. Then 0k with k0, again this will give you 0. And finally 0k with 0k, 0 zeros are 0, and k times k is k squared. So we end up with this matrix here. You'll see once again we have k squared on the diagonal and zeros everywhere else. So this must be another enlargement, but this time with a different scale factor. So it's an enlargement, scale factor k squared this time, with center 0, 0. In this question we need to use matrix multiplication to show the transformation A followed by B is equivalent to a single rotation. So let's first of all look at the transformation A, which is a reflection in the y-axis. That corresponds to this matrix here. Then we have transformation B, which is also a reflection, but this time in the line y equals x. That corresponds to this matrix here. Now if we're going to do transformation A followed by transformation B, we actually multiply the matrices in the reverse order. So we need to work out the matrix of BA rather than AB. So BA would be matrix B times by matrix A. This will give us a 2 by 2 matrix answer. So let's do 0, 1 with negative 1, 0. That gives you 0. 0, 1 with 0, 1. That gives you 1. 1, 0 with negative 1, 0. That's negative 1. And 1, 0 with 0, 1. That's 0. So this matrix here is a matrix which represents the transformation A and transformation B following after. We've been asked to show this as a single rotation, where you should recognise that this matrix is actually a rotation 90 degrees clockwise about the origin. In this question we're going to use all of these digits to make a number, but it needs to meet the criteria we've been given. We're first of all going to notice that it says it must be even. Now looking at our digits, the only even ones are 2 and 4, which means our number must end in a 2 or it must end in a 4. So I'm going to separate it into those two cases. The first case where it's a 6-digit number that ends in 2, and then also a 6-digit number that ends in 4, since these are the only ways of making an even number. Now we've also been told the number must be greater than 300,000 and less than 500,000. This tells us the first digit must be a 3 or a 4, since if it was any of the other numbers it wouldn't be in between those values. So let's look at the case again where the number ends in a 2. So if the number ends in a 2, the first digit must be one of the 3 or the 4, so there's two possible ways of selecting the first digit. Now if we look at the last digit, we've said it has to be a 2, and there's only one way of selecting a 2, that's by selecting the 2, so we put 1 here. Now for all of the other digits it won't actually matter what we choose, as long as we don't choose one of the numbers we've already chosen. So we've already chosen 2 of those digits, so there's 4 left. So to select this digit here we could say there's 4 ways, but now that we've selected that digit, there's only 3 ways, and once we've selected that one there's only 2 ways, and for the last one there's only 1 way, since we must only have one number left. So the number of ways of making the 6-digit number that ends in a 2, that's also between 300,000 and 500,000, is 2 times 4 times 3 times 2 times 1 times 1, which gives you 48 different ways. Now let's have a look at what happens if it ends in a 4. Well, if it ends in a 4, it can no longer begin in a 4. Remember earlier we said it must start with a 3 or a 4. Now if it can't start with a 4, it must start with a 3. So there's only actually one way of picking the first digit now. It must be a 3. There's also one way of picking the last digit. We've said it's going to be a 4. And then we do just like we did before. There's 4 ways for this one, 3 for this one, 2 and 1. If you times all of these together, you get 24 ways. So there's 48 ways if it ends in a 2, 24 ways if it ends in a 4. So if you add those together, you get a total of 72 different ways. and that's your answer to the question. In this question, we're looking for the angle of elevation of the camera at Y from the point G. So let's first of all connect G to Y, and then also draw a line from G to F at the horizontal here, and you can see the angle we're looking for, the angle of elevation, is this one here. So let's look at the information we've been given. We've been told the height of the sports hall, which is represented by CG, is 8 meters. We've also been told some information about the heights of the two cameras. So the camera at point X is 90% of the height, and the camera at Y is 80% of the height. So if the height of the sports hall is 8 meters, let's do 90% of that. You can just multiply it by 0.9, and that'll give you 7.2. So the height of the camera at X is 7.2, and then do the same idea but with 80%, so 8 times 0.8 gives you 6.4. So the camera at Y is 6.4 meters high. Next, we're going to look at the line from G to E. We're going to find the length of this line by looking at the triangle GEX, which is on the side of that sports hall. So if we look at the triangle GEX, it looks like this. We have the height of the camera at 7.2, and also this angle given to us at 18 degrees. Now we want to find GE, which is the base of this triangle. We can do that using trigonometry. So let's label the triangle. We've got H, the hypotenuse here. This one's the opposite, and this one's the adjacent. Since we're trying to find the adjacent, we can use tan. So we can say that tan of 18 equals the opposite, which is 7.2, divided by the adjacent, which is the one we don't know, which is the length GE we're trying to find. If you rearrange this, you'll end up with GE equals 7.2 divided by tan 18. Type this into your calculator and we find the length of GE at 22.159 and so on. Let's put this onto our diagram. Now we're going to look at the base of the sports hall, specifically at the triangle GEF. So if we draw out triangle GEF, it looks something like this. We know the length from G to E, we've just found that out, that's 22.159. And we also know the length from E to F because that's the same as A to B, which is the length of the sports hall at 40 meters. We can now use Pythagoras to work out the missing side on this triangle, which would be GF. So if we use Pythagoras, we do GF equals 40 squared plus 22.159 and so on squared. If we type the right hand side into your calculator, taking care to make sure you use the exact value for the 22.159 and so on, you get GF squared equals this. Then if you square root both sides, you get GF as this number here. So let's also put GF onto our diagram. It goes here. Now we're going to look at the triangle with the red dashed lines. That's triangle GFY. It looks something like this. We know the height of this triangle from F to Y, that's 6.4, the height of the camera, and we just found out this length for the base from G to F, that's 45.7278 and so on. Now we're trying to find the angle in this question, so that's this angle here, so we're going to call that X. Now we can just use trigonometry once more, so if we label the triangle, we've got hypotenuse, opposite, and adjacent. To find X here, we're going to need to use O and A, so that's tan. So tan of X will equal 6.4 over 45.7278 and so on. And then to find X, we're going to use inverse tan, so if we do inverse tan of this number, again taking care to use the non-rounded version in your calculator, you'll get this number here. Now the question says to give your answer to the nearest degree, so we're going to round that to the nearest degree, which will just be 8 degrees, and that's the answer to the question. In this question, we have the graph of y equals 9. That's the horizontal line that's going through P and Q. This tells us the coordinates of P and Q must both have a y coordinate of 9. So it's something 9 and something 9. Now we also have a second graph here, it's x squared plus y squared equals 225. That's the circle. Now since the points P and Q are also on this circle, and we know they have y coordinate 9, we can use the equation of that graph to help us find the x coordinates. So if we write out x squared plus y squared equals 225, but replace the y value with 9, we can find the corresponding x coordinates. So let's write x squared plus 9 squared equals 225. If you square 9, it's 81, so it's x squared plus 81 equals 225. If you subtract 81 from both sides, you get x squared equals 144. And then if you square root both sides, you get x equals plus or minus 12. So this tells us the x coordinates of those 2 points are 12 and negative 12. Now in the question we've been asked to find the area of the triangle PQR, so I'm going to draw on 2 tangents, one at Q and one at P, something like this, that meet at R. Now we're going to try and find the equation of one of these tangents. I'm going to go for the right one, the one that goes through Q and R. To do this, I'm going to draw a line from O to Q and work out the gradient of this line. Since the point Q has coordinates 12, 9, and the origin is of course 0, 0, I can find the gradient of this line just by doing the change in y, which is 9, divided by the change in x, which is 12. So the gradient of the line from O to Q is 9 over 12. This of course simplifies to 3/4. Now since a tangent meets a radius at 90 degrees, I know that the line that goes through Q and R, the green one, is perpendicular to this. So the gradient of the line QR must be the negative reciprocal, which is -4 over 3. So I now know the equation of the line that goes through Q and R has a gradient of -4 over 3. So I'm going to try and find the intercept as well by writing y equals -4/3 of x plus c. So c must be the intercept of this line, which must also correspond to the coordinates of r, since r is on the axis. So let's pick a point on the line. Well, the only one we know is the point Q, which is 12, 9, and substitute those values in. So let's replace x with 12 and y with 9. So instead of y equals, it's 9 equals -4 over 3, lots of 12, and then plus c. So 9 equals, if you do -4/3 of 12, you get -16, and then plus c. And then you can find c by adding 16 to both sides, and c is 25. So the equation of this line is no longer y equals -4/3 x plus c, it's y equals -4/3 x plus 25. Now remember, since 25 is the y-intercept, we know the coordinates of r, which is 0, 25. Now we have the coordinates of all points of the triangle, we can try and find its area. So the triangle we're looking at is this one here. If we work out the base of the triangle, that's the distance from P to Q. Now if the x-coordinate of P is -12 and for Q it's +12, the total length from P to Q must be 24. And then we need the height of the triangle. Well, if the horizontal line is at a y value of 9 and r's y value is 25, the vertical distance of that triangle must be 25 take away 9, which is 16. So to work out the area of that triangle, we can use the formula 1/2 times the base, which is 24, times the perpendicular height, which is 16. You can type this into your calculator and you get the answer 192 square units. For the first part of this question, we need to show the volume as given by this formula here. To find the volume of a cuboid, you just multiply all of its lengths together. So the volume would be x times 3 minus x times x plus 5. To approach this, I'm going to multiply the double bracket here first. So volume equals x, and then inside that we're going to do 3 times x, which is 3x, then 3 times +5, so plus 15, then -x times +x, which is -x squared, and finally -x times +5, which is -5x. We can then simplify what's inside the bracket a little bit, so we've got a 3x take away 5x, which is -2x, and then we just got this plus 15 minus x squared. We can then multiply through by this x, so we've got v equals, if we do x times -2x, that's -2x squared, x times +15 is plus 15x, and x times -x squared is -x cubed. Now you can see this is almost exactly the answer, we've just got the terms in a different order, so we can write v equals 15x minus 2x squared minus x cubed. In the second part of this question, we need to use differentiation to find the maximum possible volume. So we have the formula from the previous part that looks like this, and to find its maximum volume, we're going to do dv by dx. So if we differentiate this, the 15x will give us 15, we've got -2x squared, that will give us -4x, and the -x cubed will give us -3x squared. So we've now found dv by dx. At a maximum or minimum, this must equal 0. We've been told it's a maximum in this question we're after, so let's write dv by dx equals 0, which is 15 minus 4x minus 3x squared equals 0. This is just a quadratic equation to solve. Now we don't normally have a negative coefficient of x squared, so let's take all of the terms to the right side instead to get that x squared back to positive. So if we take away 15, add 4x and add 3x squared to both sides, we end up with 3x squared plus 4x minus 15 equals 0. This quadratic factorizes, so we get 3x minus 5 and x plus 3 equals 0, which give you two solutions for x. The first bracket gives you x equals 5 over 3, and the second bracket gives you x equals -3. Now if you think about it, one of these solutions doesn't really work. If x equals -3, then the height of this cuboid will be negative, which of course doesn't make any sense, so we can disregard that solution. Now this isn't the answer to the question though, the question wants the maximum value of v as x varies. So we found the value of x that gives the maximum volume, we just need to use it to find the volume. To do that, we'll go right back to the first formula we used in the question, v equals this. So we're just going to substitute this x value into that formula. So 15 lots of x, which is 15 lots of 5 over 3, minus 2 lots of x squared, and then minus x cubed. You can just type this straight into your calculator and you'll get this as your answer. The question asks for 1 decimal place, so that would be 14.8, which is your answer to the question. In this question we need to show an identity is true. So we're going to start with the left hand side and make sure we end up with the right hand side. So let's start with the left hand side. I'm going to leave 1 over cos squared theta alone, and then for the right fraction I'm going to multiply both the top and the bottom by cos theta. This will mean my denominator is cos squared theta, which means I can add the fractions together, since they'll have a common denominator. So if we multiply by cos theta on the top, we get 2 sine theta times cos theta, and then also minus cos theta times by cos theta, so minus cos squared theta. And on the bottom there's a cos theta, but that's also multiplied by cos theta, so cos squared theta. And you can now see both fractions have the same denominator, so we can write them as one single fraction, which is 1 plus 2 sine theta cos theta minus cos squared theta over cos squared theta. The next thing I'm going to do is make use of an identity you should know. Sine squared theta plus cos squared theta is identically equal to 1. I'm going to replace this 1 here with sine squared theta plus cos squared theta. So if we write that fraction out again, but replace that 1 with sine squared plus cos squared, and then we've also got plus 2 sine theta cos theta and minus cos squared theta. So we end up with this massive fraction here. You may notice at this point though that these two will cancel out. Cos squared theta minus cos squared theta is 0. So we can now write this as sine squared theta plus 2 sine theta cos theta over cos squared theta. Now this next step might seem like we're going backwards in a way. We're going to rewrite this as 2 separate fractions again. So we're going to have sine squared theta over cos squared theta, and the second one, 2 sine theta cos theta over cos squared theta. Now there is an important reason why we're doing this. You should know another identity, which is sine theta over cos theta is tan theta. This means the first fraction is actually just tan squared theta. And if you look at the second fraction, well, we've got cos theta on the top and the bottom, so we can cancel the cos theta on the top, and one of the cos thetas from the bottom, which leaves us with 2 sine theta over cos theta, and if we use this identity once again, that's 2 tan theta. And that's what we were trying to show. For the second part of this question, we need to solve an equation. If you look at this bit here, you'll see it perfectly matches the expression we had on the left-hand side in question A. So we could replace this with the right-hand side of that identity. So instead of all of this, we're just going to write tan squared theta plus 2 tan theta, and the right-hand side equals 3. We now have an equation in tan to solve. If we subtract 3 from both sides, we get tan squared theta plus 2 tan theta minus 3 equals 0. We can factorise this to give you tan theta minus 1 and tan theta plus 3 equals 0. We can now split this into 2 sets of solutions. We get tan theta minus 1 equals 0, and if you add 1 to both sides, you get tan theta equals 1. And also the second bracket, tan theta plus 3 equals 0, and if you subtract 3 from both sides, tan theta equals negative 3. Now we can solve both of these separately. Let's start with the left one. If you do inverse tan of 1 on your calculator, you'll get your first solution as theta equals 45 degrees. Now tan is one of the nicer functions to work with. To find extra solutions, you just add or subtract multiples of 180. So if we add 180 to this, we'll get another solution. That's 225. Now if you add 180 once more, you'll go past the 360, so they're all the solutions for the first equation. Now for the second equation, you do inverse tan of negative 3, and that gives you this as your answer. But that's not inside our range because our range needs to be positive. So if we add 180 to this, we get our first real solution, which is 108.4. And if we add 180 to this, you get 288.4. And again, if you add 180 once more, you'll fall outside of the range. Just beware, this trick only works with tan. With sine and cos, you've got different approaches. But again, I've got a video on that if you want to go and check it out. Now all that's left to do is write all of our solutions. We usually write these in numerical order, so theta equals 45, 108.4, 225, and 288.4 degrees. Thank you for watching this video. I hope you found it useful. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.